Okay. Well, once again, my name is Nuke Energy, and I am on the negative side of the topic at hand, which is nuclear power. I'm going to address what my opponent said and challenge the disadvantages and workabilities of their arguments. So first of all, I'm going to talk about the cost of nuclear power plants and how they may seem expensive but are in actuality not. First of all, I'm going to tell you that building a new nuclear power plant can be and will be an economical and financial challenge. A resurgence of nuclear power poses significant challenges to the economy. Contrary to a few years ago, estimates for new nuclear power plants have skyrocketed. The current average estimate of is $9 billion per plant, which will lead to a large rate of increases and threaten the financial viabilities of many companies. The U.S. would still be relying a lot on other countries for their resources. Approximately, according to the government website for education of nuclear power plants, only 14% of uranium comes directly from the United States. Well, at least this is in 2008. The other 86% comes from all the other countries which have uranium. The average cost for decommissioning a power plant is $300 million. I got this from nuclear.info.net. And this funds for this activity are accumulating operating the cost of the plant. The non-uniformity of each of the plants also affects the cost. The U.S. nuclear power industry never achieved economies of volume because every reactor was different. Each developer put in their own tweaks, and much of the equipment was custom built for each plant. This compounded the difficulties of obtaining the NRC licensing approval, since they had to evaluate each individual design, which I also got from nuclear.info.net. That's it for the cost. That's my section for that cost. I'm also going to talk about the radioactive waste. Although the storage of waste is the waste is stored in nuclear power plants so far. They're coming up with the Nevada thing, but it's still quite unsolved. It takes 10,000 years for, according to the U.S. Environmental Protection Agency, it takes about 10,000 years for a nuclear energy waste to not be dangerous anymore, and there's no way to speed up the rate of decay, which I got from Associated Content, an article of Associated Content. And yes, for that higher level nuclear waste, there isn't a permanent way. Like you would have to watch over the nuclear waste for all those years to make sure nothing happened to it. There are potential consequences with nuclear. If anything were to happen, there'd be long-lasting effects over large areas. And for fossil fuels, with the current approach, if something happened, locally they would be severe, but they would be short-term and wouldn't be over a span of a large area. And nuclear power waste can potentially be very, very dangerous, and it could be potentially widespread contamination of air and water, and this would happen for hundreds of miles around the reactor. So if there were any kind of meltdown or any kind of outside contamination, it would be very widespread and dangerous. So that could be a very very dangerous problem if anything were to happen to any of these reactors. Like, if something unpredicted happened, then it would be very catastrophic. And that's all I have on those two topics. Thank you.